Assalamu alaikum. Dear students, how are you? I think all of you are well in grace of Almighty Allah. I am also fine. I am Hiron Chaudhary, Associate Professor and Head of the Department, Statistics Department, Eden Mohila College, Dhaka. Welcome to all of you on behalf of Eden Mohila College online class. Today's topic is Contingency Table, which is second year non-major course statNM 202, that is Principles of Statistics. At first, what is contingency table? We know when data are qualitative characteristics that we cannot measure this data, we measure this data their quality. So when observations are classified according to two qualitative variables or attributes and arranged in a table, this display is called contingency table. When observations are classified according to two qualitative variables or attributes and arranged in a table, the display is called contingency table as shown below. Contingency table. Suppose two variables, variable B, variable A. B1, B2 up to B are A1, A2 up to AC. Total, that is total. These observations 1, 1, 1, 2, 1, 3, 4, 2, 1, 2, twice C, R1, R2, R C. If we total this row and this column, then we get this is first row, second row, that is R, that is column C1, C2 up to CC. Total observation N. When the data are classified according to two qualitative characteristics and display in a table, this table is called contingency table. Contingency table are shown as below. The general procedure of test of independent is independent is general procedure. Number 1, at first state null and alternative hypothesis. State null and alternative hypothesis. Null hypothesis: there is no association between two variables. There is no association between two variables. that is they are independent. Alternative, there exists a relationship exists, a relationship exists. We set up null hypothesis, there is no relation between two variables, that is they are independent. Alternative hypothesis, there is relationship between two variables, that is a relationship exists. This is step 1. Step 2. Step 2. Select a random sample and record the observed frequency in each cell of the contingency table and calculate row, column and grand totals. Select a random sample and record the observed frequency. Observed frequency in each cell. That is, if we select a contingency table, then we select random sample and then we divide in each cell the sample observations. So this is called observed frequency, and we calculate row total, column total and grand total. Step 3. Calculate the expected frequency for each cell. This is observed frequency and we calculate expected frequency for each cell. This theory is equal to expected frequency equal to row total to column total divided by grand total. That is, in general, Eij equal to Ri into Cj by n. I equal to 1 to R, J equal to 1 to C. This is general theory to find expected frequency. Eij equal to Ri into Cj by n, grand total n. Ri means row total, Cj means column total and n means grand total. Step 4. Compute the value of test statistic. Compute the value of test statistic chi-square equal to O minus E by E whole square. This is simplified as O square by E minus n. Compute the value of test statistic chi-square equal to summation O minus E whole square by E. That is simplified as summation O square by E minus n. Step 5. Calculate the degrees of freedom by the formula. Calculate the degrees of degrees of freedom. Calculate the degrees of freedom for the following formula: D degrees of freedom equal to number of rows minus 1, number of columns minus 1, that is R minus 1, C minus 1. Step 6, using a level of significance alpha, and degrees of freedom, find the table value of chi-square. Step 6, using a level of significance alpha, that is alpha means either 5% or 1%, that is 0.05 or 0.01, it is level of significance. Next, step 7, comment. Step 7, comment. If calculated chi-square less than tabulated chi-square at alpha percent level of significance and degrees of freedom, then A0 is accepted. Otherwise rejected. This is finally comment. If calculated chi-square less than tabulated chi-square, then A0 is accepted, otherwise rejected. This is our general steps procedure in test of significance, to test the significance of contingency table. An expression for 2x2 contingency table. An expression for 2x2 contingency table. Our 2x2 contingency table is, let A, B, C, D total A plus B, C plus D, A plus C, B plus D, N equal to A plus B plus C plus D. Our 2x2 contingency table is this. Under the hypothesis of independence, expected, this is observed frequency A, B, C, D, this is called observed frequency. Now we can find expected frequency for each cell. That is expected frequency for A equal to row total, column total divided by grand total. Row total into column total divided by grand total. B row total, column total. C row total, column total by n. D equal to row total, column total by n. This is expected frequency for each cell. We know chi square equal to A minus E whole square by A plus B minus whole square by EB, C minus EC whole square by EC plus D minus ED whole square by ED. This is number 1. Now we can calculate this value and put these values in this equation. We can find an expression for 2 by 2 contingency table. Now A minus EA equal to A minus EA, A plus B, A plus C by N, and this is A plus B plus C plus D minus A plus B, A plus C. After calculating AD minus BC by N. Similarly, we can calculate B minus EB minus AD minus BC by N, C minus EC minus AD minus BC by N, D minus ED equal to AD minus BC by N. Put these values in equation 1. We get AD minus BC whole square by N square 1 by EA 1 by EB 1 by EC 1 by ED. we put this value we put these values N A B A C plus N A B B D plus B B plus D plus N A C C D and B D C D. After calculating, we get AD minus BC whole square A plus B plus C plus D plus B A plus C B plus D C plus D. That is AD minus BC whole square equal to A plus B A plus C B plus D C plus D. This is the required expression for 2 by 2 contingency table. So viewers, no more today. See you again next another day inshallah. Thank you all. Allah Hafiz.